Kids, welcome to day 2 of Unit 10. Unit 10 feels pretty choppy to students, I think, because we do kind of jump from topic to topic. It's our last unit, so it's kind of just a wrap up of stuff. So remember, day 1 we did parametrics and calculus with the parametrics. Parametrics is related to vectors, right? They're really just different ways of writing things, writing the same thing. And then both issues, though, are getting time into the situation. So with vectors, velocity, again, is going to be a first derivative. Acceleration is going to be a second derivative. Direction of motion sometimes is a formula, and I'll talk about what that is. But sometimes when they talk about path, it's like I did with parametrics, right? You're just drawing arrows, using your calculator and drawing arrows, right? And saying, what is where's the direction of this thing going as time is passing? Speed is the absolute value of velocity. Okay? So I'm going to go through each one of these scenarios. So firstly, you have a smooth differentiable functions for your horizontal and your vertical. The position vector then can be written in 2 ways, and it doesn't matter how you write it as long as you can read it. The position function, often called r, sometimes with an arrow above it to indicate vector, sometimes bolded. But here's the component vector notation. Component form. I call this I and J form, and often I and J are also bolded to indicate they are unit vectors. It is a linear combination of the unit vectors I and J. Again, don't care. You don't have to know what it's called. You just have to recognize the notation. Velocity vector, first derivative. So it's just taking derivatives piece by piece. The acceleration vector is taking the second derivative piece by piece. So for example, a particle moves in the plane with this position vector, so you might want to highlight what you are given and highlight what you are asked for. So you have a calculator. You know how to put it in parametric mode, right? It's going to be the same thing as, there's no vector mode because they really are the same thing. And you're just going to write, this is your horizontal, this is your vertical component, and you're just going to take derivatives of sine 3t, don't forget the chain rule, and cosine 5t. So there's the velocity, the acceleration, and then the path. Again, I'm just putting this into my calculator. There it is. I'm going to hit trace to get time. There's my point, right? Time equals 0. And then I'll hit trace and I'll watch how it moves, and I'll draw some arrows on this thing, right? It probably won't be, it will not be as complicated as that, right? They're not going to have you spend time drawing tons of arrows. And then hello derivatives. Now, don't forget, each one of these is a vector because each one of them is in terms of t. It's not a value. You would give me a value out of these vectors if I gave you a t. What is the velocity at t equals 1 second of that particle as it moves along that curve? And by the way, that curve is kind of, you don't need to know this. It is called a Lissajous, which you can see up here, Lissajous. Okay, there you go. Let's do another example. Right, that wasn't that bad. And even though I have my calculator, I didn't really need it to find those derivatives, right? So same thing. Speed, I want to define speed, and this is in your, this is on your handout, second page. The speed of the particle is the magnitude of the velocity vector and is a number. Speed is a number, it is not a vector. Oh, I want to be on pen, silly. Speed is a number, and it is always positive, right? Those bars mean magnitude, but they also still indicate positivity. So if you are asked for the velocity, your value at a certain time, your value might be positive or negative, but if you are asked for the speed, but since we are in vector land with a horizontal and vertical component, it isn't just a matter of taking an absolute value of a number, right? It's the absolute value of the magnitude, and you see that formula, which is just, hello. Yep, Pythagoras. And remember, it is not a vector. So there's your speed. Make sure, look at your notes. I think I corrected it, but there was a typo. I just like copied over dy dt twice. But right, it should be dx dt squared and dy dt squared, square root of. Now don't get this confused with the length. The length is the integral of a bunch of, right, those hypotenuses. But there's your speed. Now direction, you aren't often asked for the direction on the AP exam. I don't, right? We may ask you on a quiz or a unit test, but I don't believe, I can't remember seeing direction asked on a free response or multiple choice of AP. But it is just your velocity vector divided by speed. So you do get a vector out of this because you are taking a vector and dividing it by a number. Right, so you're just scaling each one of these vectors. It's a unit vector, right? Kind of, sort of. Right, it's the velocity vector divided by the magnitude of the velocity, right? So it's a unit vector. It's just not the I and j unit vector. So notice here, direction of motion isn't path. If I ask you for the path, I'm just asking you to draw arrows. That I've seen on the AP exam. I haven't seen direction of motion, but it still is part of the, right? Still part of the curriculum. So yes, we will assess you on it. And you've got some homework problems on it. So here is, right, the same vector, sine 3t, cosine 5t. This time find the speed and the direction. So again, you want to make sure that you highlight what you have. I'm given position, and they want me to find speed and the direction of motion at a particular time. So I'm going to be generating some values, not, right, not just vectors in terms of t. So it's the same graph, my same Lissajous. Oops, sorry. My same Lissajous. So my speed is the absolute value of the velocity vector, which I found on the last slide. So it was the derivative of x with respect to t, which is 3 cosine 3t all squared plus negative, although who cares because I'm going to square this, sine 5t squared. But don't forget you're putting in 2. Right, I just did this on my home screen and I got almost 4. But I stored that in alpha A because and I didn't write that down on my paper, right, anywhere, but with my calculator, I stored that in alpha A because I know for direction of motion, I'm going to need to take the velocity vector and divide it by its magnitude, but I'm not going to divide by a rounded number, right? I will write this down, But with my calculator, I will not actually divide by 3.962. I will divide by alpha A. So my vector at a particular value, right? And I have my calculator. I don't have to write this down. I wrote what I'm going to do. So I don't have to actually, I'm actually, though, dividing this again by A. And don't forget, I should put this at 2. The vector at 2 divided by the magnitude at 2. And I will round these answers to 3 places past the decimal. Okay. You have a calculator. Set up, answer. Set up, answer. And again, just like before, since you've probably already defined dx dt and dy dt, you could just write dx dt squared plus, at 2, dy dt squared at 2. You could even just write this, and then just write dx dt and dy dt as long as you've squared them, add them, and then get an answer. Okay. Take advantage of having your calculator. All right, distance and displacement. So just like we did in, first semester, distance versus displacement. Distance is total steps you've taken. So regardless of whether you've gone right, left, up, or down, think absolute value. And displacement is where are you how many steps does it look like you've taken? So in other words, if I'm going right and left, and I go 5 steps to the right, and then 2 steps to the left, my distance is 7, but my displacement is 3, because it looks like, I went 5, it looked right. I actually took 5 steps to the right and then 2 steps back. But if you didn't watch me move, it looks like I'm just at 3 when I'm done, that I started at 0 and I'm stopped at 3. So notice that these, I'm now talking about integrable functions, which again don't have to be differentiable, but they do have to be continuous. The displacement from time equals A to B is a vector. No, a vector of 2 integrals, that I can have in component form, or I can put it in IJ form. Again, it doesn't matter how you write it, as long as you can read it either way. But don't forget that if somebody asks you not for displacement or distance, and I guess I didn't write this down, that the distance would be the absolute value of those, Maybe I have it later and I just forgot, but it's the integral of the absolute value, The position, though, you have to add where you've started your position. Think plus C, So you need to add the initial position. Where were you at the first time when you're done? So for instance, up here, when I said, oh, let's suppose I started at 0 and I went 5 steps to the right and then 2 steps back, it looks like I was at 3. But what if I told you I started at 10? If I started at 10, sure, I went 5. I still traveled 7 steps. And it still looks like I only took 3 steps. But I didn't, where did I end, Because I started at 10, I would have gone to 15 and then back to 13. If I start at 0, I went to 5 and back to 3, So your initial position matters, but you have an initial, add your initial X position to the X component and your initial Y position to the Y component if they ask you for position, not just distance or displacement. Oh, there I did. See, I did. Total distance is the integral of the absolute value of velocity. Yes. Hey, where have I seen that formula before? That's the length of a curve, baby. Isn't the length of the curve the distance that you traveled? I think so. Woo! nuts, or I should say nut. All right, so what am I given? Be careful, please. Be careful. Look at what you're given. You are given a velocity vector. Velocity. You are given at time equals 0 your x position and your y position. And then they are asking you to find the position at t equals 4 and the total distance traveled between 0 and 4. Right? So, given velocity, the position is going to be the integral of velocity gives me position, and I want to go from 0 to 4. So that's the x component. And the y component is the integral from 0 to 4. The velocity x, I should say. And this is the velocity y. But more importantly, when I get that displacement, what do I have to add? At time equals 0, since you're starting at 0, at time 0, where were you already? Oh, no. Well, I don't have to write that. But in the y direction, when time was equal to 0, where was I? I was already at 1. All right, so I wanted to highlight the important part before. Now let me write this correctly. So what is the velocity in the x direction? What is the velocity in the y direction? No, they won't take, they'll be upset, but they won't take off points if you don't have the dt. Now, these are not hard to do by hand, integrating 3 cosine 3t and negative 5, but if you have your calculator, please don't. If you have your calculator, you math 9 this and get an answer. You don't have to show any integrals. You math 9 this, but you freaking add 1. And when I was done, I got negative 0.536. Certainly check my math on this. And I got 0.408. Okay. So again, don't forget here, you were given velocity. Now, initial value problems, notice that in the problems I just did, you were actually given the initial condition, right? You were given, and you just had to make sure to add it. For initial value problems, you have to solve for the plus c. So I'll show you what that looks like. So new problem. Suppose a particle, blah, 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 velocity vector of this at t equals 0. So again, highlight what you're given. Smooth. I'm given a velocity vector, and I'm given at time equals 0. The particle is at 1, 5. Determine the path. I already highlighted it for you. Determine the path that the particle travels in 4 seconds, going from my initial Okay, so I know at time equals 0 where I was, but they're asking me for given velocity, they want the path in this time. And I know I said if I want to indicate a path, but that's when they gave me the position vector. Determining the path is your position vector. Indicating the path is drawing arrows. All right, so I need R of t is what I'm after. So if they gave me velocity, how do I go from velocity to position? Integrate, right? So I'm going to, now did I write this? Yes, I did. So I'm going to integrate velocity in the x direction to get position, right? R of t in the x direction. This is R of t in the y direction. Two integrals. But don't forget, I need to know the plus c. I know where I am at time equals 0. So you'd think to yourself, well, shouldn't I just add 9 and add 21? No, no, no. Right? Now I have a calculator, so I am going to math 9 this. Oh, I can't math 9 it. Why not? Nope. This is how, even though you have a calculator, they're going to get some actual integration in there. That's not what I wanted to do. So, but this isn't bad. T squared over 2 minus 3 sine pi over pi, right? I'm just use substitution. Plus c. There's me working in the x direction, right? So I integrated plus c. How do I solve for c? Well, what do you know? At time 0, where were you? Right? So this equals the x component of r of t. Maybe I'll write it like that. I need to solve for c. Well, what t can you plug in? 0, right? And what position did you have then? At 1, when t was 0, what is c? Well, in this case, c was just 1. But what about over here? R of t in the y direction is the integral of this. So that's t squared over 2, but we'll cancel out with that 2. Plus, right? Cosine of pi t. Where did this pi go? Where did that pi go? I didn't even mention that over there. Where did those pi's go? Right? With u substitution, they're going to cancel out. Plus c. Again, what do you know? You know that at time 0, the y component, y position was 5 at time 0. Pi times 0 is 0. Cosine of 0 is 1. So therefore, my final r is the combo of t squared over 2 minus 3 sine pi t plus 1, comma, t squared plus cosine pi t plus 4. if you put that in oh, didn't mean to do that. So ugly. All right. So this is the path. And notice what happens when you plug in time equals 0 to that. What is R of 0? You want to check your work. R of 0 means plug 0 in here, plug 0 in here, and you get 1. Plug 0 in here, 0 plus cosine of 0, which is 1, plus 4, which is 5. OMG. Crazy. All right, we have on your note sheet, you have another example to go through, right? Where I work mostly in I and J form. I'm going to save that for our live session. But if you want to go ahead and do it on your note sheet and then just compare with the answers that we have in our live session, that would be swell. All right. Oh, I did forget that I had the path. Once I found that R of t, here's what R of t looks like, right? And I just did it in parametric mode where I broke up x and y. Pretty crazy. Notice that on the xy plane, it's not a function, but look at all the function math, the derivatives and the integrals that I can do, right? Even though the graph on the xy plane isn't a function. It's kind of cool. All right. I will see you in our next live session. Oh, bye-bye.